Hi guys, Audrey here. So today we're going to be talking about elasticity. What is elasticity or price elasticity of demand? So price elasticity of demand is a function that allows us to see how consumers will react to a change in price. And it does this by allowing us to see how revenue will change when the price changes. So when the price increases, we know that people are probably going to buy fewer items, but the question is, are they going to buy a lot fewer, like hardly any, or are they just going to like change their buying habits an itsy bitsy little bit? So then in this way, we can see how revenue will be affected. Will revenue actually go up even though you increase the price and fewer people are buying? Or will so fewer people buy that revenue actually decreases? So this is what our elasticity of demand function tells us. Now, it is specifically considered to be the relative rate of change of quantity demanded, which is X, divided by the relative rate of change of price, which we'll call P. Or in other words, it's the percent change in quantity demanded over the percent change price. So the letter or the function that we use to describe this is this sort of cursive in, and that's pronounced eta. So we say that eta is the percent change quantity demanded over the percent change price. Now, there's this other thing that's called the law of demand. Sorry, hang on, give me a sec. Why isn't this working? There we go. The law of demand. And the law of demand states that an increase in price corresponds to a decrease in units sold. So in other words, when price goes up, the number of units that we sell will go down. And when price goes down, the number of units we sell will go up. And most goods follow this law. There are, however, some goods that don't. Most of these goods are called Giffen goods or Veblen goods. So a Giffen good would be a good that is so necessary for life that people are going to keep buying it even if the price goes up. But especially because it's necessary, but more than that, it's maybe also cheaper than the other items. So an example of this might be bread. So for people that don't have a lot of money, bread is often the cheapest option. It's going to be cheaper than meat, it's going to be cheaper than vegetables, and so they probably end up eating a lot of bread. So if the price of bread goes up, they still need it, they're still going to buy it. But more than that, because it's cheaper than these other goods, it's still cheaper than the meat, it's still cheaper than the vegetables, they maybe have less spending power to buy those other things, so they'll actually buy more bread. So this is what's called a Giffen good. Now, a Veblen good would be a luxury good, so this could be something like a Prada handbag or something like that, where when you increase the price, you're sort of increasing the desire for it, you're increasing the value, the luxury, so maybe more people are going to buy it, even though you're increasing the price. Now, these goods do not follow the law of demand. Now, in this class, they're important largely in that we won't be thinking about them. We're only going to consider goods that follow the law of demand. Okay, so with that said, we now kind of understand what the law of demand is, what elasticity is, this percent change in quantity demanded over percent change in price. That's giving us an idea of how consumers react. Now we want to come up with an actual function for it. So we've said that elasticity relates revenue to price and units. So we're going to think of our formula for our revenue function. R was equal to price times number of units. Now we're going to think of this revenue function to start with as a function of x. As a function of x. So what that means here is that my x is the variable. So the derivative of x will just be 1 because it's the variable. But the derivative of p, we're thinking of p as a function of x. So how will the price react when the number of units demanded or sold changes? So that we don't know the derivative of p is p prime. So we're kind of thinking of this implicitly. So let's go ahead and do the derivative of the revenue function. R prime would equal to the derivative of the first, that's p prime, times the second, so that's x, plus the first times the derivative of the second. Well, the derivative of x, we said, is 1. So r prime is p prime x plus p. Now I'm going to do something a little bit weird, and we'll see why in just a second. I'm going to factor out that p prime x. So I'm going to call it xp prime, factored out. When I factor it out of itself, we have a 1 left over, plus now we're going to have p over xp prime. Okay, so let's think about the different parts of this. First of all, I know that for sure x is positive. I know that x is positive because I'm not going to sell a negative number of units. That doesn't make sense. In the same way, p is positive because I'm not going to sell things for a negative price. Now, when we think about the law of demand, we know that p prime is negative. This is because when x goes up, so as x increases, my p is going to be going down, and we're going to have that negative slope. So the derivative is negative because the function is going to be decreasing. As x goes up, p goes down. So p prime is negative, x goes up, p goes down. And then we're going to think about this p over xp prime that shows up here. So p over xp prime, if p is positive and x is positive, then p over xp prime must be negative because p prime is negative. So p over xp prime is negative, but then this xp prime, for the same reason, will also be negative. So this right here is a negative value. Now, I know that the derivative of revenue, in other words, marginal revenue, if it's positive, will tell me that revenue is increasing. And if it's negative, it will tell me that revenue is decreasing. So we can see that whether revenue is increasing or decreasing is entirely a question of this p over xp prime's relationship to 1. So in other words, revenue is increasing. So r prime is positive, meaning revenue is increasing. Revenue is increasing if 1 plus p over xp prime is also negative. That first part's negative, that second part would also have to be negative to make it positive. So if this is also negative, which will happen when p over xp prime is less than negative 1. So in other words, if x goes up, we know that p goes down, and my revenue will be an increasing function. We said that this was a function of x, so x up means r up, if p over xp prime is less than negative 1. Now, r prime less than 0, so revenue is decreasing. If 1 plus p over xp prime is greater than 0. So that first part's negative, so if the second part's positive, we're going to have an r prime that's negative, so decreasing. Now, this will happen when p over xp prime is greater than negative 1. So this is x up, p down, because that goes together by the law of demand, but x going up, here revenue is decreasing, so if x goes up, my revenue function is going to be going down, so this would be revenue down. So revenue is decreasing if that p over xp prime is greater than negative 1. So this p over xp prime here then, it tells me how revenue is changing when the price changes or when the number of units change. It is how consumers are reacting to a change in price. So it's actually my eta function, my elasticity function. But that's really when we were thinking of revenue as a function of x. We might often want to think of revenue as a function of price, because really we're saying, how does revenue change when price changes? So we could also think of revenue as a function of price and do exactly the same thing that we just did. So revenue would be p times x. But if we think of it as a function of P, then in this case, that would mean that X is my function. So the derivative of X would be X prime. We wouldn't know what it is. And the derivative of P would be 1 because we're saying that is our variable. And if we do the derivative of revenue thinking of that, well, then we do the derivative of the first, that's 1, times the second, plus the first, so that's P, times X prime. Now I'm going to do the same thing I did before. I factored out that first term, that P prime X. So now I'm going to factor out my X function, that X there, and I get 1 plus P X prime over X. And in the same way as before, we can see that, I'm sorry, I forgot my prime here, our prime. We can see that whether revenue is increasing or decreasing is entirely a function of this px prime over x. So this is also thinking of my eta function, but now we're thinking of it as a function of p instead of as a function of x. So we actually have 3 different definitions of the eta function. Eta was equal to the percent change quantity demanded, over the percent change in price. And then when we thought of revenue as a function of units, it was this P over XP prime. And then when we thought of revenue as a function of price, it was Px prime over x. Now there are a few things we could do to show that these are actually the same thing, but we're just going to go into trying to understand what they all mean. So now let's go back to this sort of analysis we did of that P over XP prime and its relationship to revenue. We can actually separate elasticity into 3 cases. So our first case would be that first thing we looked at when revenue was increasing because P over XP prime, in other words, eta was less than -1. So if eta is less than -1, in this case, we say that the good is price elastic. And this is what happens when consumers are reacting strongly. So consumers are reacting strongly. We also said, if we are looking at this first thing, it's what happens when the number of units increases, revenue increases, which would mean that my price would decrease. So in other words, this was when X went up. We know that P went down in that case, and then revenue went up. So if I want to increase revenue in this case of elasticity, the thing to do would be to decrease my price. So this is when it is elastic, we want to decrease the price to increase the revenue. Now, the last thing that we'll say here is that when we look at this percent change quantity demanded over percent change price, if eta is less than -1, maybe that's something like -3 over 2, that's showing me that the top part is bigger than the bottom part. So in other words, this would be when the percent change in quantity demanded is greater than the percent change in price. So this is why we say that consumers are reacting strongly, because their reaction to a change in price is going to be greater than that change in price. Maybe we just change the price a little bit, we just increase it a little bit, but people are like, oh, no, it's not worth it anymore, I'm not buying that. Or we decrease the price a little bit and people are like, yeah, now I'm going to buy all the things. So that is in the case of elasticity, when we are the good is price elastic. Now our second case here is when eta is greater than -1. And in this case, we say the good is price inelastic. So this is when consumers are not reacting strongly. And if we go back up to where we did that little analysis, this is going to be the case where eta was greater than -1. So when x went up, revenue went down. So x up goes with p down always, that's the law of demand. But in this case, that would mean revenue would go down. So this is x up, p down, same as above. But now with my eta greater than -1, my revenue is also going down. So in this case, if I decrease the price, my revenue is going to decrease. So it would make more sense to increase price to increase revenue. Now, just a tip about how to remember this, the way I think about it is all of the ins go together. So if it is inelastic, then I need to increase price to increase revenue. If it is elastic, then I'm not going to increase the price, I'm going to decrease the price. If it's inelastic, I want to increase the price to increase my revenue. In this case, the reason we say that those consumers are not reacting strongly is because the percent change quantity demanded is actually less than the percent change in price. So even if we change the price a lot, that means that the consumers aren't really changing their buying habits all that much. So that is why the consumers are reacting strongly. And in this case, we want to increase price to increase revenue. Where did that C go? All right. So the last case that we have here, case 3, is the only case that's left. It's the case when eta would be equal to -1. Well, let's go back up here and look at our price elasticity function. Our price elasticity function, that xp prime times 1 plus p over xp prime. Well, if p over xp prime is equal to -1, my revenue function, my derivative of my revenue function equals 0. And we know that that's a critical value. And in fact, that's where we have a horizontal tangent line. And we know that those are the places where maxima and minima occur. Well, because of the nature of p prime always decreasing, x prime always decreasing, x positive, p positive, it actually turns out that in this case, that is a maximum. So when eta is equal to -1, we say that the good is unit elastic. The good price is unit elastic. Unit elastic. And this is actually the perfect price to optimize revenue. This means that consumers aren't really reacting at all. If I increase the price, they're going to buy the same amount more. If they decrease the price, we're going to buy the same amount more. So this is the optimal price. Price to maximize revenue. So whatever price it is when eta equals -1, that's the good price. That's the price we want. The consumers aren't overreacting. They're not underreacting. In this case, the percent change in quantity demanded equals to the percent change in price. So if I increase the price, revenue is going to go down. If I decrease the price, revenue is going to go down. We want to stay at this price. All right, so those are our 3 elasticity cases. Now we just have to do some questions. So we'll do that in the next video. See you guys then. Bye.